All right, this is our fourth lesson on systems of equations. The previous three were things you should have learned in ninth grade, so they should feel review-like. This one is also a little bit review-like, but also a little bit new. So what we're doing today is studying systems of linear equations and quadratic equations. Okay, so essentially we have a parabola and a line and parabola. Okay, so there's three occurrences that you might see. In this situation here on the left, this is no solution. There is no intersection between the line and the parabola. We could also get one solution. This is if the line just touches the parabola in one spot, right? It's tangent to the parabola. Or we could have two solutions. This would be where the line goes through the parabola and hits it in two places. I want you to ask yourself, could we have infinitely many solutions if we have a parabola and a line? The answer to that is no, we couldn't. A line will never take the same shape as a parabola and vice versa. So in order for the lines to be infinitely many solutions, it had to be multiple lines at the same exact place. So they had the same y-intercept and the same slope. That's how they were able to have infinitely many solutions. So when we're doing this combo, you will either have no, one, or two solutions, never infinitely many. Okay, there are two types of problems. One is graphing. So let's start by graphing the line. We've been practicing this recently. Your y-intercept is at -5, and the slope is 2. So to change that to a fraction, we could just put a 1 under it. The 2 is telling us to rise 2, and the 1 is telling us to run 1. Since they're both positive, we're just going to go in those directions, up and to the right, up and to the right. Okay, and then we'll connect those dots, and we've got ourselves a line. All right, now we're going to graph the parabola. And we have done this, but it's been a little while maybe. So what you want to do is identify the vertex. And this quadratic function is not written in vertex form, so we need to do a little bit of work to find that. The expression that we want, which I hope by the end of this year and maybe even sooner you're able to bring to mind, we want to use opposite of b over 2a. So if we have an equation, a quadratic equation in standard form, this little formula is going to help us find the first number of the vertex. So a is 2 on this problem, and b is -8, right? The linear term coefficient. So opposite of b would be just 8. Since b was -8, we're going to do the opposite of that, which is +8, over 2 times a. A is 2, so we're looking at 2 times 2, so our denominator is 4. 8 divided by 4, let's simplify that. It gives us 2, right? So the vertex for this problem, I'm running out of space, the vertex is going to be at 2 comma something. To find the second number in our vertex, because it's an ordered pair, we're going to plug in x to our quadratic function. So I'm going to replace each of these x's with a 2 and see what answer I get. So 2 times 2 squared, that's going to be 8. Minus 8 times 2, that's -16, plus 3. 8 minus 16 is -8, plus 3 is -5. So the vertex for this problem is at 2, -5. Go to the right 2 and down 5. Now the slope is dependent on the a value. So since we know that a is 2, the first slope is going to be 2. Rise 2, run 1. And we run in both directions here. And then I teach my students to, the changing slope is affected by a factor of 135. So the initial slope, we multiply a times 1, so 2 is 2. The next slope, it changes. The next slope is going to be a times 3. So that'll be 6, right? 2 times 3. So we rise from that point that we just graphed, we're going to rise 6. 1, 2, 3, 4, 5, 6, and right 1. So that's it. And then we go the opposite direction. 1, 2, 3, 4, 5, 6, and left 1. Okay. So, perfect. I'm graphing this, and we have 2 points of intersection. So to finish this off, we're just going to name those points. This one on the left is at 1, -3. And this one on the right is at 4, 3. Okay, so you'll have some graphing equations, and they could have no solution, one solution, or two solutions, like the one we just did. All right, we also are going to solve algebraically. So substitution is going to be our go-to method for this. And we're just going to work through the example and find all the things that we need. I might, if I were making these notes, I might add in here that we want to solve for 0. That's how we usually solve quadratics, is set it equal to 0 and then solve. Okay, so what I'm going to do, when both equations are already solved for y, I'm going to take this expression, y equals this, and I'm going to replace that y with negative 12x plus 36. All right, so when I do my new equation after I've substituted, will look like this. So essentially it's this top line, but I replaced the y with this expression. Okay, what we're going to do now is I have found in my years of factoring that having the quadratic term's coefficient be positive is super useful. So I'm going to leave the x squared right there since it's positive, and I'm going to add 12x to both sides and subtract 36 from both sides so that I have 0 equals everything else. In fact, that's going to be x squared plus 1x minus 72. Okay, now we've practiced solving quadratics through 4 ways: factoring, square root method, completing the square, quadratic formula. This one, it's factorable, so that's the method I'm going to use. I've taught my students to use this X method, we call it. It's just sort of a visual device to help us identify what we're looking for. So up top we put A times C, that's 1 times negative 72. And at the bottom we put the B value, in this case that's 1. Now on the sides I'm looking for two numbers who have a product of negative 72 and a sum of 1. Right, so these two numbers are 9 and 8, but I need one of them to be negative, and I'm going to choose the 8 to be negative so that when I add them I get positive 1. So my factors are x plus 9 and x minus 8. They just keep the same sign as I write the factor there. Okay, to solve this, we're looking for what value of x makes x plus 9 equal 0. And that is negative 9. And what value for x makes x minus 8 equal 0? That one is 8. Okay, so now we have two solutions, right? We're going to have an ordered pair that has negative 9 for its x value and a second one that has 8 for its x value. And I'm going to go ahead and plug them into the linear function. That's a little bit easier, I think, than the quadratic, but either one will give you the same answer. So if I do negative 12 times negative 9, that's going to be 108, plus 36 is going to be 144. And then if I replace the x with 8, I will get negative 12 times 8, that's negative 96, plus 36 is negative 60. So we have these two answers. And that's what the homework has, is just a handful of problems where you're solving a quadratic and a linear equation using substitution, right? We want to find out what x and y are in the two solutions, one solution, or a no solution. Okay, good luck.